All right, good morning, guys. Sorry, I'm out today. It was kind of unexpected. Just not feeling very well. So, um, went ahead and started the notes for us. So this is 3.4 linear models. Some of this I'm going to walk through with you, and then some of it I'm going to have you try on your own, and I'll post an answer key a little bit later today. But the first part here, it says, use the table below, plot the points on the graph. Okay, so this is actually going to be a scatter plot. I've went ahead and graphed this already, but if you want to pause the video and go ahead and graph it yourself. But a scatter plot is a set of ordered pairs graphed on a coordinate plane. So very similar to the graphs that we've been working with. The only difference is, as you can see, they're kind of scattered throughout, right? They're not in just a straight line. Some of them are off a line and whatnot. I believe last year you probably talked about line of best fit, and that's essentially what today's assignment is over. So we're going to look at different scatter plots. We're going to draw a line of best fit. We're going to try to estimate that line of best fit and then use it to estimate where other points may be, right? So it's a very statistical type of way of looking at some data and saying, okay, well, here's what data I have. What can I predict that may happen in the future, right? So they use these type of models on, let's say, weather forecasts. They use it on bacteria growth, viruses, etc., things of that nature. Okay, so 3 oranges, 1.027. And I tried to do my best here, but this is not a very easy graph, right? So we would usually use Desmos for this and plug it in. But again, it's fine either way. So try to match them up. 3, 1.025 or 27. 4, 1.162 is a little bit above that, etc. All right, from there, we're going to draw what we call a line of best fit. Now, a line of best fit, one thing to remember, it says a line that represents the data by going through the middle of the data points, is we always try to connect at least 2 to 3 points. And we try to make like the number of points on either side even. This isn't perfect. It's just a way for us to try to make sure we have the best line of fit. Okay, so in this case, like I'm going to pick 2 points that I think, like if I kind of draw a line right there, it looks like it goes through. And you can see that I actually am connecting this line, or that point and that point, right? So I'm connecting some points, and then on either side, on either side, I have 1, 2, 3, 4, 5, 6. So I've got 3 and 3 on each side, and so that's a pretty good estimate for a line of best fit. I'm actually going to take this line all the way down here just so I can see what that point is. Okay, and that's our line of best fit. So from here, we're going to try to estimate what that line would be so we can plug it into our calculator and estimate some future points, right? And so in this case, what's the slope? Excuse me, a little voice break there. So slope is how much it goes up and over, right? So if let's say I go here and then I go up, that's a 0.5, so I go up to 0.1, which would be up 0.5, and over, so this would be a 0.5 increase, and this would be, let's see, it kind of goes from what looks like 1 to maybe 3, so that's an increase of 2. Now this is just an estimate, but that's rise over run, right? Rise over run. So our slope here would be 0.5 over 2. If you want to double that, you can, and it's really 1 over 4, right? Because if I double 0.5. So that's my slope. Now, what does that slope mean in this case? Well, we're talking about oranges, and specifically how many oranges we have and what the weight is, right? So in this case, if I go up is going up weight, and going right is going up number of oranges. So for every 4 oranges, where it goes up 1 ounce, is that ounces? Kilograms, excuse me. 1 kilogram per 4, I'll just write the number 4, oranges. Okay, so that's what it means in terms of this. Okay, now it says using the line you drew, estimate the weight of the box with no oranges. Okay, well that's what I did here where I extended it. So you take this line, you extend it all the way down, and that would be 0 oranges. So we would estimate that. It looks like it's 0.25, 0.5, 0.75, 1, 1.25. So this is really close to 0.25. I would argue maybe like 0.3. Okay, again, this is an estimate. You might have said 0.4, and that's okay, but this is 0.3. And what part of the graph is that? That is our y-intercept. Okay, that's where it touches the y-axis, so 0.3. So now we have enough where we can actually write an equation, and it's one that's very familiar to us, y equals mx plus b, where we have our slope, right? This is our slope, the m, and the b is our y-intercept. So even though we didn't have an equation initially, we just had a bunch of points that we could graph. Once you draw that line of best fit, you can estimate what the slope is, and you can estimate where the y-intercept would be. And again, this is just an estimate that we're trying to help us predict. So this would be y equals, our slope as we set up here is 0.5 over 2, or you could write 1 over 4. I like 1 over 4. It's a little bit cleaner. X plus whatever your y-intercept was, which in this case we said was 0.3. Okay. So now for number 4, it says using your line or equation, estimate the weight of a box containing 11 oranges. 11 oranges, right? Will this estimate be close to the actual value? Explain your reasoning. Okay, so we're going to go ahead and type in, or fill in, I guess, substitute an 11 for where the x was, right? Because oranges is on the x-axis, so we plug it in for x. So that gives us y equals, let's see, when you multiply that, it gives you 11 over 4 plus 0.3. If we want to convert all of this to be decimal form, which we should, 11 over 4 is, let's see, 2 3/4. So I'm going to write this off to the side. It's actually going to be 2 3/4, which tells us it's 2.75. So this is really 2.75 plus 0.3, and that gives us about 3.05. So it's saying, will this estimate be close to the actual value? Explain your reasoning. Possibly, right? We're using the line of best fit, so you would think that it would be close. Will it be the actual value? Probably not. It's just going to be close, but that's okay. All right, continuing here. Using your line of equation, estimate the weight of a box containing 50 oranges. Okay, so now we write this out. 1 over 4 times 50 plus 0.03, which we know would be 50 over 4 plus 0.03. And we're just substituting 50 oranges because, again, it's to the x. And so now 50 divided by 4, let's see, is 12.5. You could use your calculator for this if you wanted to. Oh my gosh, I'm using 0.03. It's supposed to be 0.3. Gosh, hopefully if we were in class, you would correct me on that. So 0.3. Don't blame me, just not feeling very well. All right, so that would give us 12.8 roughly. And that would be kilograms, right? I guess this would be kilograms as well. Okay, so it gives you an idea. You know, if we don't have 11 oranges, or hey, I need to know how much weight it's going to be carrying. This is about what it's going to be, even though not every orange is exactly the same weight. It gives you an idea. So like, how big of a container do you need to carry 50 oranges? You know, what's the shipping costs going to be if you're not shipping your own product, etc. My uncle actually has a peach farm, and so they've got to be able to tell, like, okay, genuinely speaking, if I throw 15 peaches in this basket, how much weight is that, and how much can I sell that for, and all those different things, right? The graph at the right, moving on to the state test examples, represents a relationship between the temperature and ice cream sales. Graph the following equations on the graph, then determine which equation best describes the data. Okay, so again, this depends on where you put your line of best fit, but I'm going to try to go through maybe that first one, and let's say up through that one, and you can see that that connects 1, 2, kind of 3, 4 dots, right? Maybe even 5 dots if you think about it. So that's a pretty good line of best fit right there. I've got 1, 2, 3 dots above, and I've got like 1, 2 dots below. So it's not perfect, but it's a pretty good example, okay? And so from here, we would just identify which one it goes with. Well, the easiest way to start when you're trying to identify for a state test question of which one it might be is look at the y-intercept, okay? So our y-intercept here is definitely not 0, so it can't be A and it can't be D, so it has to be B or C. Well, 50 would be down here, so that tells us this is probably closer to 150. However, you still need to kind of look at the slope just to make sure we didn't put our y-intercept in correctly. So based on this slope, it looks like it goes up maybe like, if I go up 100, it goes over that far, maybe 4 units-ish. So then 100 over 4 we know is 25, which matches up with that 25 for the slope. Okay, so it's a quick way to estimate when you get to the state test is to try to draw that line. Even though it's on the iPad, you'll have scrap paper, so you could do that as well. And then it says, using the equation you selected above, estimate what ice cream sales would be on the day that's 21 degrees Celsius. Okay, well, temperature is on the x-axis. So we're going to use this equation, y equals 25x plus 150. And we're going to take that temperature, 25 degrees Celsius, 21 degrees Celsius, plug it in there, add 150. Now, I don't know what this is off the top of my head. Let's see. 25 times 20 would be 500. Add another 25. So that should be 525, I believe, plus 150. Let's use a quick calculator. Yep, 525. Man, I'm good. Okay. So that gives you $675 in sales. Okay. What can you conclude about the relationship between temperature and ice cream sales? So looking at this graph, as the temperature is increasing, what's happening to the sales? Is it going down? Is it going up? Well, as the temperature increases, ice cream sales go up, right? So as temp increases, so do the sales. And we would call this a positive correlation, which we'll come back to later. Okay? Because it's a positive slope. Okay, what I'd like you to do now is go ahead and kind of that same idea. So describe the relationship. Okay, you've got your axes that are labeled. And so you see this graph. They've drawn the line of best fit for you. They've given you the equation already. Describe what the slope means in terms of the graph. So the fact that this is going down, right? This is a negative slope. What does that mean in terms of the age in years and the reaction time? Okay, number of bananas, price in dollars. I want you to write that out over here. I'm going to post that on the answer key later, as well as an answer key to the Check Your Understanding, which is your homework for this weekend. Hopefully you guys can finish that by the time you're done in class and or freshman focus. And of course, if you have any questions, reach out to me on Canvas. All right, I'll see you guys on Monday.